Hi, today we're going to learn about volume. So our objective is to find the volume of rectangular prisms, and this is page 64. All right, well, volume is the number of cubic units needed to fill a given space. So if I had a container and I wanted the volume, I would see how many of these cubes would fit into the container. Okay, so first of all, volume is measured in cubic units because you can see it's a cube and it has three dimensions. It has length, width, and height. So if you look at my example right here, I could say this is the length, the width, and the height. There are three dimensions. It's three-dimensional or 3D. Okay? It doesn't really matter which one I call length and width and height because I could also turn it, and now this could be the length, this is the width, and this is the height. Okay? So on this picture, if I wanted to find the volume, I could, number one, count all the cubes, which would be kind of difficult and take a long time. Or I could just multiply the length times the width times the height. So that's one example you can see right here. Let's look at a few other ways that I could do this. Well, if I have a cube, the neat thing about cubes is they're made from squares. And so that means every single side length is the same length. So if the formula originally is volume equals length times width times height, well, on a cube, the length, the width, and the height are all the same number. So that's why it can also be written as one side to the third power, because this would mean side times side times side, which is what ends up happening because the length, the width, and the height are the same number. So for this one, volume equals 4 to the third power. And remember, that means 4 times 4 times 4. It does not mean 4 times 3. Now, when I solve this, I can do the first two. 4 times 4 is 16. And then I would bring down this other 4. 16 times 4, well, let's see. That's 24. That's 4, 5, 6. So the volume would equal 64. And then it's centimeters. So centimeters cubed. So I have a little exponent of 3 when I do volume, because it's how many cubes, cubic centimeters, would fit into this shape. All right. So when I have a rectangular prism, now I could also call this a rectangular prism, so that's why it still counts for what we're doing for volume today. But for a rectangular prism, that means I might have rectangles on the side. I mean, I could still have some square surfaces, but in this specific shape, I have rectangle, rectangle, rectangle. All my sides, all my faces of the shape are rectangles. So this is a formula that you may have seen before, length times width times height. Well, this formula right here is what we're going to start using and what you're going to be using in the future. So I want you to get familiar with that. Now, it looks like it says base times height, which you might think, hey, well, that's area. But capital B and a lowercase b mean different things. So a capital B means the area of the base. So looking at this area, if area is length times width, this capital B is basically standing for the L and the W. So really it's still length times width times height, but what they're doing is they're counting the base of a three-dimensional shape as in one side. So I could call this whole piece right here the base, and then so the area of this base times the height. So on this figure, it really doesn't matter which side I call the base because I could turn that figure. So I'm going to go with this side since we can see it easily. I could say that this right here is the base of my figure. So I'm going to kind of shade this so you can kind of see what I'm talking about. So this right here, I can find the area of this piece, which would be length times width. So that's why the capital B means the same thing as length times width. And then I could take that area and multiply it by the height, which I can call 6 in this case. So we're going to practice using this. Volume equals area of the base times height. The area of the base means length times width. So my area of my base would be 2 times 3. And then I would multiply that by the height. So you can see it's still length times width times height. But this is all they're going to give you on your chart. So I want you to be familiar. All right, so then I would multiply 2 times 3, and that's 6. So the capital B is really just 6. The area of this base right here is 6. Then I bring down this times 6. So then my volume equals 36, and it's feet cubed, or cubic feet. Okay, let's look at the next one. So I have another rectangular prism, and I'm going to find the volume. So again, I'm going to use this formula, volume equals area of the base times height. Well, I'm going to have to just pick where I want my base to be, and I'm going to pick it to be right here, what it seems to be resting on in the picture. So that means from here to here to here to here. So this is what I'm going to call my base. Okay, and to find capital B, which means the area of this base, well, I need the length and width. So length and width, because those are my sides of this base. So that would be 10 times 8. And then I would multiply that by the height, which would be times 12. So 10 times 8 is 80. And then I would do 80 times 12. So let's see, 80, 12, 0, 16, 0, 8. So volume equals 960 centimeters cubed. Okay, now let's look at some word problems. So the first one says, a cereal box holds 495 cubic inches of cereal. The box has a width of 2.2 inches and a height of 18 inches. What is the length of the box of cereal? Okay, well, the first thing I want to do is try to sketch or draw a picture that could help me. So cereal box, I'm going to try to draw a rectangular prism that looks sort of like a cereal box. So I know it kind of looks like a rectangle. And I'm going to do like this to try to make it look 3D. Okay, so here's my cereal box, and technically, if you could see through the box, it would kind of look like this. Okay, it says it holds 495 cubic inches. Well, let's think about this. What is measured in cubic inches? Volume. So it has already told me the volume. So the volume equals 495 inches cubed. Okay. It says the box has a width of 2.2 inches and a height of 18 inches. So I'm going to label this 18 inches, and I'm going to just label this 2.2 inches. And it says, what is the length? So this L is what I'm trying to find. Well, I know the formula is volume equals area of the base times height. And I know that the base stands for, or the area of the base is length times width. So really, volume equals length times width times height. Okay, so let's plug in what we know. I know that the volume is 495 cubic inches. I don't know the length, so I'm going to keep that an L. I know that the width is 2.2, and I know that the height is 18. All right, so what I'm going to do is try to simplify anything I can. I can multiply these together, so I'm going to start there. 2.2, 18, 8 times 2 is 16, 16, 17, 2, 2, 6, 9, 3, and I've got a decimal, so right there. So now this would be 495 equals L times 39.6. All right, now when I look at this, it looks like an equation from the last 6 weeks. So if I see that there's multiplication, if I want to undo that, I need to do the inverse to get the variable by itself. So I'm going to divide by 39.6. So I'm going to divide by 39.6 on this side, and that means I have to also do it on the other side. This will cancel out because that makes 1, and just leave the length. So now really I just need to solve this, and it should tell me my length. So let's see. 495 divided by 39.6. Remember, I can't have a decimal in my divisor, so I need to move it to the right. And if I move it here, then my decimal has to move also. So now my decimal's right here. Okay, so 396 would go into 495 once. And then I'm gonna subtract. So 15 minus 6 would be 9. 18 minus 9 is 9, so I'm left with 99. I have the 0, I bring it down. All right, 396, that probably would go in twice. So let's see. I'll use this space. 396 times 2. 18, 19, 6, 7, 792. Yep, and it would not fit in again, so it's going to go in twice, which is 792. And now I have to borrow, so that's 8. 18 minus 9 is 9, and that's 1. I'm going to add a 0 and bring it down. Ooh, man, okay. So this is really close to 400, and that's really close to 2,000, so I'm going to guess it goes in 5 times, and let's check and see. 396 times 5, so 30, 45 for 6 for them, 48. 5 times 2 is 15, 6, 7, 8, 19. Oh, perfect. So that's 5, and that would leave us with 0. So then our length is 12.5, and this was inches, so inches. Woo! Okay, so if you're already given the volume and you're looking for one of the dimensions, like it doesn't tell you the length or the width or the height, basically you're just going to multiply the two that you do know, and then you have to divide that with the volume to get the other length. Now, how could I check this? Well, multiply the length, the width, and the height. So I can multiply 12.5, 2.2, and 18, and then make sure I get back to this 495. Okay, last word problem. The bottom of a rectangular pool has an area of 330 feet squared. If the pool is 8 feet deep, how many cubic feet of water will the pool hold? How many gallons of water would this be? All right, so first of all, let's draw a picture. So we're gonna assume this is the shape of a rectangular prism because it says the pool's rectangular and then it has a depth. So in this case, deep, the depth is the same as the height because it's just going down as opposed to up, but it's still the same dimension. Okay, so let's try to draw a diagram. Let's pretend like here's the ground. We're gonna say this is an above ground pool. Here's the ground, here's the top of the pool. So now I'm gonna just kind of show what the pool looks like this is under the water. So this is into the ground. Okay, close enough. So here's my pool. This is the top of the water right here, and then this is if I were to dive down into it. So it says that the bottom of the pool, so down here, so let me use a different color so that it stands out a little more. So here's the bottom of my pool. And it's already told me the area of this right here. So the area of the bottom of my pool, in other words, the area of the base, so capital B equals 330 feet squared. And first of all, it wants me to find the cubic feet, so it's looking for volume. Well, let's do the formula. Volume equals area of the base, which is capital B, times height. Well, I already know the area of the base. So volume equals 330 times the height, which is the same as the depth, times 8. So I just need to multiply those, and it's going to tell me my volume, or the cubic feet of water. So 330 times 8, 0, 24, 24, 25, 26. So volume equals 2,640, and that's feet cubed, or cubic feet. That's my first question. And the second part says, how many gallons of water would this be? All right, so each cubic foot holds 7.5 gallons. So I had to take my volume and I had to multiply it by 7.5 since there were 7.5 gallons in each cubic foot. So when I multiply that out, I ended up getting 19,800 gallons, which sounds like a huge number, but it's actually a pretty reasonable size pool. Okay guys, so just remember, overall we can do length times width times height, but you're gonna see on your formula chart capital BH, which means area of the base times height, okay? Area of the base is found by doing length times width, so they mean the same thing, but you need to be familiar with seeing it in this format, okay? So just remember, make sure you multiply all three dimensions and that will give you volume. All right guys, keep practicing and thanks for watching.